Congratulations.
Recording in progress.
All right. Okay. So let's just review SOHCAHTOA stuff again. So remember when we had a unit circle, it looks kind of like that, right? And remember, this is a length of 1. That was 1. That was -1. And that was -1. And then we had some sort of radius, right? And some angle. We call it theta. That's kind of hard to read. So it kind of looks like this, right? Now, we're going to call this R. Even though the unit circle this is 1, sometimes we're going to be dealing with trigonometric functions with hypotenuse is not 1. So I'm just going to call the hypotenuse R. I'm going to call this X and Y. So X squared plus Y squared, of course, equals R squared. And where's that from? X squared plus Y squared equals R squared. That's Pythag, right? So that's where this comes from also. These are the same thing. The only difference is that R is isolated, right? So they just square root both sides. They're the same. Okay.
They just not write out the. What's the point of even adding roots to square root of X squared plus Y squared?
You'll see when we get to example 1.
Not write it out yet, but they already did that with the R.
Right. Exactly. So just backtracking a little bit. If we backtrack a little bit, sine theta, remember SOHCAHTOA, right? SOHCAHTOA. So sine theta, if you look at how it's set up, if you SOHCAHTOA, sine theta would be what over what? Using this triangle here. Sine theta would be what side over what side? Y over, it would be Y over R. Cosine theta would be adjacent for hypotenuse, right? So what two letters am I going to compare? X over R, exactly. X over R. And then finally, tangent theta is going to be over A, Y over X. So it's almost like the unit circle. This is like the unit circle, but R may not equal 1. It could equal 1, but it may not equal 1. So we need a general way of finding sine, cosine, tangent if you have a variety of situations. We're going to see those various situations for the following examples. But Y over R is sine, X over R is cosine, Y over X is tangent. Okay. Now, the other ones are just flipped, right? We know this. The other ones are just flipped. R over Y, R over X.
So sin is flipped with CSV.
Exactly. I know it's kind of weird, but yes, I know. It is a little weird. So cosecant goes with sine. And don't worry, I'll give you guys like a formula sheet. Don't worry about that stuff. Like I'll tell you like cosecant is 1 over sine, secant is 1 over cosine, so you don't get them confused. Oh, wow. I'll give them to you. Don't worry about it. Yeah, cotan is 1 over tan. But of course, you need to know the Pythagorean theorem: X squared plus Y squared equals R squared. SOHCAHTOA, you need to know that also. Now, with that said, let's take a look at example 1. Now, if you look at example 1, you have 3, 10 as a point on terminal side of theta. So here's what's happening with. So this is not a unit circle. So example 1 is not unit circle, and I really want to emphasize that because some people will confuse. So here's what some students will do. I'm about to do something that's wrong. I don't want you doing this. Okay, let me erase some stuff because I need some space here. All right. So here's what some students will do. They'll see this, and it really drove me nuts when I taught this class in 2018, I would say, or maybe in 2017. And I was like, or my son was like 6 months not sleeping well, so I was probably a little cranky, but it drove me nuts that people would see this and they say, oh, well, sine theta is 10 and cosine theta is 3. And then we get tangent right. Tangent would be 10/3. But they tell me that sine theta is 10. What is wrong with that? Why is that so bad to say that sine theta equals 10? If someone could tell me, I'll give you an extra credit on the next test. If someone could tell me, give me a really good answer. Okay, if you're saying sine theta is 10, then here's what you're telling me. You're telling me that's 10, and that's 1.
That can't be. Yeah. The hypotenuse is 3. It has to be the biggest side.
Thank you, James. You got extra credit. Okay. I don't know, maybe a couple points. Here's the deal. What is sine to begin with? Sine is opposite of hypotenuse, right? So katoa. Trig functions are ratios. That's all they ever are. Sine is a ratio of 2 sides, right? Cosine is a ratio of 2 sides. Tangent is a ratio of 2 sides, right? That's what trig functions ever are. They're a ratio of 2 sides. Output, the input's an angle. That's what you put inside the function. What you get out of it is a ratio of 2 sides. So if you're telling me sine is 10, what's 10 as a fraction? Yeah, any whole number is a fraction. What's on the bottom of it? 1. So then you're telling me that the opposite is 10, the hypotenuse is 1. Can the hypotenuse be shorter than the leg? No. Why? Because isn't the hypotenuse opposite 90? Isn't 9 the largest angle? Yes. And it has to be the longest side. So if you use just some logic, so it drove me nuts because what it told me is that students were just memorizing and not really understanding. It was probably second semester seniors. That's what we taught. I like that we're doing it now because I know the seniors will be distracted in the spring. But it just drove me nuts because they were just using the unit circle. Because the unit circle, of course, sine is y. Why is it y? Because on the unit circle, r is 1, right? On the unit circle, r is 1. So you could just use the y coordinates. If it's unit circle, this is not unit circle because where are your coordinates? 3, 10. If your coordinates are 3, 10, and again, just use a little logic. And sorry, I'm getting a little amped up here because I just had bad memories a few years ago. Just really drove me nuts. If you have 3, 10 as a terminal side, so here's your angle. It looks like this. So the circle is going to look kind of like this then. It's a really big circle. How would I find that radius? That's 3, and that's 10. If I do Pythagorean theorem, that's root 109. Root 109 is not 1. The radius is not 1. So this is not a unit circle. So the radius is not 1. So play a question. Oh, sorry. I glossed over that. It's a Pythagorean theorem because you have 3 this way and 10 this way. So you do 3 squared plus 10 squared, which is 109, right? Because what's 3? Yeah, and then that has to be the square root of x squared plus y squared, right? So that's not a unit circle. That is not. So that's why I just got really upset when my students would do that. It's like, no, this is not what you do. So actually, I kind of already did it for you guys, this problem. So how do you actually do this example? Here's what you do. Really simple. You figure out what r is, which actually I just did for you guys. It's going to be 3 squared plus 10 squared, which is root 109. Okay. And sine theta is y over r. Sorry. My handwriting sucks. I'll do it again. My apologies.
Oh, that's R. Sorry.
Nope. My handwriting's terrible. Okay, my apologies. There we go. That's much better. So that's an r. So sine theta is y over r. Cosine theta is x over r. And tan theta is y over x. Now, if these were coordinates on a unit circle, remember the coordinates in a unit circle were these fractions or these radicals, right? On the unit circle, you got this, right? Like that was like root 3 over 2, comma 1/2. If you were to actually do x squared plus y squared, you get 1. If you were to do that. But this is not a unit circle. 310 is a much bigger circle, right? That's the point on a much bigger circle. So your sine theta is just going to be 10 over root 109. Your cosine theta is going to be 3 over root 109. And the tangent is to be 10/3. And again, just to do a quick sketch, it looks like this. I'm not going to draw 10 tick marks. It's kind of crazy. If you do a quick sketch, it looks like this. Make that 3. Okay, that's a much better drawing. And so that's 3. Goodness. That's 3 and that's 10. That's root 109. And so that's where you're using the SOHCAHTOA stuff, right? 3 of root 109, 10 of root 109, or 10/3. Okay, so hopefully that makes sense. So please, please, please don't misconstrue this. I don't expect that to happen because I've made it so clear. This is not unit circle. It's like it, but it's not. Because 3, 10 makes a circle with a radius greater than 1. Okay. So don't just give me the y or x coordinates. You have to do y over r, x over r for sine and cosine respectively. Questions before I do example 2 and talk about the reference angles? No?
If you don't want us, if we ever calculate on a test, you ever want us to simplify root 109?
I don't care. No, I don't care. Because in calculus, we don't care. And I'm getting you guys ready for calculus. So no, I don't care. And calculus teachers don't care either. We made you do an algebra 2 and algebra 1 just so you know the process, but yeah, I don't care. All right, reference angles. Before I do example 2, a reference angle is let me type it up, that would be easier. It'll be an acute angle formed between the terminal side and the x-axis. So let me give you an example. I'll do it off to the side here. Then we'll do example 2.
What's the terminal side again?
Where it ends.
Like, is that in reference to like a triangle?
Not quite.
It's like, how would you know which side?
I'll show you. So what if I had this right here? So theta equals 150 degrees. Now here's the question. If I were to form an acute angle, and this is the terminal side, by the way. The terminal side is right there. If I were to form an acute angle less than 90 between the terminal side and the x-axis, what would that be? What would be the measured angle between the terminal side and the x-axis? 30. Take the spell. It'd be 30. Yes. It'd be 30 degrees. So my reference angle would be 30 degrees. The bottom line is the reference angle is the shortest possible distance you can get to the x-axis. I'll give you another example. I'll do it on the board. What if I had 240? That's theta equals 240 degrees. What is the possible way to get this terminal side to the x-axis? Would it be this way, or would it be this way? The first one. And what's that angle going to be from here to here? That's 240.
120.
No, not quite. It's got to be acute.
Oh,
30.
60.
60, actually. Oh, wait, yeah. That, I thought the rest would be 30.
So this is called a reference angle. Now, let's look at the unit circle. If I go back to the unit circle, which I had somewhere, it's probably in this folder. Altitude trig honors, spring, chapter 13. Let me clear my drawings for a sec. All right. If you look at 60 degrees, right? Zoom out a bit more. Here we go. If you look at 60 degrees, where are the coordinates of 60 degrees? 1/2 and root 3/2. Where are the coordinates of 240 degrees? They're very similar. The only difference is a negative, right? So you can use reference angles so you know what coordinates that corresponds to, but then you make an adjustment. Just put a quadrant, make x negative, make y positive, or y negative. So it just depends on what it refers to. So any of these angles refer to this. Because these are acute angles. So that's why we use reference angles, just to simply know what large angle, what a large angle is referring to what other smaller angle. That's where it comes from. I'll use that terminology often. I mean, I kind of taught you how to look at the unit circle, but if you ever get stuck, like say, for example, I ask you to find me the sine of 240 degrees, realize that 240 is like 60. And then use the coordinates of 60 degrees on the unit circle. Or let's say, for example, we'll do one more. What if at 330 degrees? If at 330, which looks like this, that's 330, right? What will be my reference angle? 30 degrees. So you use the 30-degree coordinates, right? Use the 30-degree coordinates and then apply it to 330, but make x positive, make y negative, because you're in the fourth quadrant. So that's what reference angles are about. That's all.
I'm still so bad at like how we get like 520. You want to like graph that.
Well, 520, that's going to be 160, and that's not anything that we can get from the unit circle.
Oh, okay. So
Yeah.
every number you're gonna give us, if
From the unit circle.
subtracted or added 360, you can get.
You'll be able to identify in the unit circle.
Oh,
Right.
cool.
Okay,
Yeah.
now example 2 has nothing to do with reference. Example 2 is just like example 1. Okay, negative 2, 3. So example 2 is like example 1. Let's repeat that. Our efforts here. So negative 2, 3. Negative 2, 3. 1, 2, 3. All right. Okay, negative 2, 3 is there. Let's draw an angle. So there we go. I don't know what theta is, don't worry about it. But that's how it would look, right? So negative 2, 3 is right here. That's the terminal side. Of course, there's some angle that we can draw to it. But remember, all I ask for is find the sine, cosine, tangent. You don't have to find the angle. I don't care what the angle is. We'll just evaluate these right here. Remember, what is y again? Sorry, what is sine again? It's y over r. What's cosine? X over r. And what's tangent? Y over x. And how do I solve for r?
R equals negative
Yeah.
2.
Yep. So it's root 13. So you get 3 over root 13. Negative 2 over root 13. And you get 3 over negative 2. Okay, we're good? That makes sense? So again, just like example 1, you gotta figure out what r is. That's not hard, that's just the diagram here. In fact, actually, I could just draw it right here. But if you do a right triangle like this, that's negative 2, and that's 3. You do Pythagorean theorem to get root 13. Right? That's negative 2 going this way. That's 3 going up that way. Pythagorean get root 13. So not that hard. And remember, sine is going to be the opposite over hypotenuse. The cosine is going to be adjacent over hypotenuse. Tangent is opposite over adjacent.
Wait, how is it negative?
It's not. I mean, the sine is not technically negative.
Oh, sorry. I'm asking just because you don't take. Okay, maybe. Yeah, go ahead. You're good.
The side of a triangle is obviously a positive value, right? But I give it a negative number to show that I'm going to the left. Or if I'm going down, then I give the vertical side negative number. But that's what happens here. Now, this next part is kind of important because this will help you to generalize what to expect from sine, cosine, tangent. When you're in the first quadrant, we know x is positive and y is positive. That we should know. That's just standard knowledge from middle school. Coordinate planes, x is positive, y is positive. We're in the second quadrant, x is what now?
Negative.
And y is positive. Third quadrant, x and y are both negative. And of course, the other way around for quadrant 4. Now, given what we know about these guys here, now r is always positive. Because you're square rooting, right? There's no plus or minus on the outside. Square roots always give a positive output.
So R is always positive. Now looking over here, we're in the first quadrant. Because X is positive and R is positive, and also because Y is positive and R is positive, and you have Y over X.
All trig functions are positive in the first quadrant. Let me make that a little neater. Let me write that a little better. All trig functions are positive in the first quadrant. So if I ever give you a coordinate in the first quadrant, expect all the trig functions to be positive. If I say the terminal side end at 1, 2, sine, cosine, can all be positive. Now for the second quadrant, only sine and cosecant are positive. Now let's think about this one. In the second quadrant, only sine and cosecant are positive. Why? Because sine is Y and R. Y is positive in the second quadrant. X is negative. If X is negative, my cosine is being negative, my tangent is being negative. However, if Y is positive, that's why sine is positive. Cosine is just flipped over. Flip something over, it's just doesn't change sign.
So on the test that cosecant, like cotangent, all that stuff, the formula will be given to us?
Yeah. Mhm.
Oh, what is it?
Cosecant is 1 over sine, because I don't want you guys confusing it. Right. Now,
What does that mean, 1 over sine?
cosecant, the cosecant of an angle is 1 over the sine of the angle. They're reciprocals of each other.
Oh, okay.
This I'll give to you, so you don't confuse it. The third quadrant, tangent and cotangent are positive. The reason why is that you're dividing two negatives. If you divide two negatives, you're gonna have positive. But however, because R is positive, you have negative or positive, negative or positive. Sine and cosine are negative in the third quadrant. Lastly, cosine and secant are positive in the fourth quadrant. The reason why they're positive in the fourth quadrant is because X is positive, so X over R, that's cosine. Flip it, it's still going to be secant, that's positive. But Y is negative, that makes sine and tangent negative. So all trig functions are positive in the first quadrant, only sine and cosine are positive in the second, tan, cotan positive in the third, cosine and secant positive in the fourth. It's a lot of information, but here's just to quell any of your worries or concerns. This unit circle that I'll provide for you gives you that information. So I will give you this unit circle. You don't have to make your own. You're told in the first quadrant that everything's positive here. Sine, cosine, tangent, secant, cosine, cotangent, positive in the first quadrant. The second quadrant, so sine, cosine are positive, the others are negative. And the other ones are shown below. Again, remember, Y is a sine on the unit circle. X is a cosine on the unit circle. Tangent is Y over X. So this is the way we can rationalize this. Realize, yeah, totally. Everything's positive. All coordinates are positive in the first quadrant, so all the trig functions are positive. However, when X is positive in the second quadrant, so you're going to have sine and cosine positive. In other words, sorry, Y is positive, so you have sine and cosine positive, but not the other ones. There's actually a mnemonic. It's kind of like a PEMDAS thing. You guys come with your own if you want, but so one way I remember this, all sophomores take chemistry. Not necessarily true. I took a junior also. I did. Then I took AP Chem, then I majored in Chem. But anyway, I hated Chem, then I fell in love with it. Or all seniors take calculus, was also not true because I guess seniors not taking calculus. But anyway, you could I have one student said aardvarks sleep towards California. It's a really weird one. It doesn't make any sense, but however, whatever mnemonic you want to come up with, it's up to you. But ASTC, so that's how you can remember that. Okay. So more information you guys getting about trig. Okay, we just got one more page of stuff, and then you guys can head start on homework. All right. Now, the one thing about trig that makes this a tricky class. Now, I'm guessing your parents are probably not that much older than me, so they probably took this class when it was called pre. I took this class when I learned stuff. I learned it when I took Precalculus as a junior. But if you talk to your grandparents, who probably are like more my parents' age, who probably did math like in the 60s or 70s, you took a class called trig. So you took like geometry, you took algebra, you took trig. Those who are just super duper smart, they took calculus in high school. Now things have changed. Everyone does calculus, I guess. But what makes trig challenging is that trig is very analytical. So you're gonna have to be. What I'm asking you guys for these problems here, I'm asking you to be highly analytical. This is why sometimes people don't like trig, because they don't tap into this type of thinking, or teacher doesn't promote that. Actually, it's the teacher's fault. It's never the student's fault. It's always the teacher. If I don't promote this, then I'm failing you guys, right? So I'm telling you right now, you gotta be highly analytical in doing these problems. Meaning that you gotta take all the pieces of the puzzle and put it together. Like, good example is I'm gonna play Wordle. Or you know about Wordle, right? Okay. Actually, I didn't. Did I do it this morning? I did do it this morning. I barely got it. But you know, like they give you the letter, right? And then like maybe it's in the right place, maybe you have the right letter but in the wrong place, and you have to be able to think. And there's 26 letters in the English alphabet. You gotta like put the pieces of the puzzle together, right? That's exactly what's happening here. So you're told to find the 5 other trig functions. So you already have tan, right? So you need sine, you need cosine, you also need cosecant, you need secant. Oh, go ahead.
What is? This might be a similar question.
No, go ahead.
What is that symbol between?
Oh, it's not a dumb question at all. No. It's called element. It's a fancy math symbol. It just means it's a member. So theta is a member. So mathematicians are super lazy. We like to make things very concise. This is what it is in words. Theta is a member of quadrant 3. That's what it means. No, actually, I'm glad you brought it up. I probably would have not said anything about it.
But instead of writing all those words, you could just say the little e.
Actually, it's not quadrant 3. Sorry, it's quadrant 2. My bad. Quadrant 2. So theta is a member of quadrant 2. Okay. So that's what it means. So what I'm going to do is I'm going to draw. All right. Here we go. Oh, no good. Let's try again. Okay. So you're in quadrant 2. And it's -5 to now. Remember, this is y over x. We know tangent's y over x. So I'm going to gather, if I'm in the second quadrant, first of all, if I'm in the second quadrant, is x positive or negative?
So can you just pick values? Like,
Positive, and y is negative, right?
Yeah, y is positive.
Oh, duh. Yeah. You fooled me. I had it right. Okay. X is negative, y is positive. So if you have -5 halves as your tangent, I'm probably going to let y be 5 and x be -2. So I'm going to plot -2, 5. I'm going to plot -2, 5. So that's where you got to take the pieces of the puzzle. You know tangent y over x. I told you that.
You've seen that by that's the circle. You're in the second quadrant, so you have to be right here. So x is negative, y is positive. So those are my coordinates, -2, 5. Well,
If I know the coordinates, I can get r now, right? What's r going to be? Right, you got it. Thank you, Iris. Totally got it, right? And now we're just ready to rock and roll the rest of the problem. Sine is going to be y over, remember, sine is y over r, cosine is x over r, cosecant is flipped over from sine, secant's flipped over from cosine, and tangent is x over y. Now you can just rock through the rest of these. You know sine is going to be 5 over root 29. Cosine is going to be -2 over root 29. Cosecant is flipped. Secant's also flipped from cosine. I'm going to erase some stuff here. root 29 over 2. And lastly, you got negative 2 over 5. So what you do is you take your knowledge of what we just did in the previous stage, you know, times y for x. However, is it negative 5 and 2, or is it 5 and negative 2? How do you tell? Because this is the extra piece of information. It's like a puzzle, right? You're element of quadrant 2, so from the second quadrant, clearly y is positive and x negative. So you have to make x negative and y positive, right? Okay, let's try another one. Let's try another one here. Let's look at part B. Again, you gotta be highly analytical here. Okay, secant is negative. First of all, secant theta is r over y. Okay. So it's gonna be 2 over negative 1. Remember, r is always positive.
How do you know it's negative 1?
Yeah, how do you know that?
Well, it's a fraction. Make it a fraction. Any fraction, any number could be a fraction. What do you put below it?
1.
1, exactly. Exactly.
I negative 1
negative 2 1. Oh, because
R is always positive. R is always positive. I know. R is always positive. Okay. So, and also you know this too. Sine theta is y over r. And that's positive. So use the piece of get all the pieces of the puzzle now. Sine is y over r, and that's greater than 0, so that's positive. That means that both y and r are positive. So r is always positive because r is that. It's a positive square root. So if y is positive, but secant is negative, what quadrant do you think I'll be in? 1, 2, 3, 4. 3.
Two.
Well, sine's 2. Thanks. It'll be 2. Here's where the unit circle is going to help you guys. If you guys are a little stuck with it, the unit circle actually makes it even easier on you. Look at the unit circle. Sine's positive, secant's negative. You can use that too. Everything's positive here. Forget about quadrant 1. Your secant is negative 2, but sine when you told is positive, so you have to be quadrant 2. So you can do that also. But if you didn't have a unit circle, you could use the reasoning I just showed you. So now I know I'm quadrant 2. So y is negative. Wait. Oh my goodness. I can't believe I did that. No wonder I confused you guys. It's r over x. My apologies. It's r over x, not r over y. Sorry about that. It's r over x. R over x is 2 over negative. X is negative 1. My apologies. There we go. You have negative 1 and 2. How do I find this side? What would I do to find that side? Pythagorean theorem. Y will be root 3. So if y is root 3, then your coordinates are negative 1 comma root 3. Negative 1 comma root 3. Once you have that figured out, then we can just do the rest of the problem. I'll do it off to the margin here. We need sine. We need cosine. We need tangent. We need cosecant. And we need cotangent. Remember, sine is y over r. Cosine is x over r. Tangent is y over x. And then you flip the other ones. R over y. And that's x over y. X over y, sorry. That looks ugly. So that'll be root 3 over, oh, what's r? R is going to be 2, yeah. So that's root 3 over 2. That's negative 1 over 2. That's negative root 3. And you flip the other bad boys over. That's 2 over root 3. And negative 1 over negative root 3. Yeah, there we go. And I'll be totally straight with you guys. You never really use this stuff in calculus, just so you know. It's like this is a skill set that, like, I mean, it's good to know how these work, but the whole point of why I'm putting you guys through the ringer here, when you do move on to calculus, which is even more analytical than this class, you need to have that. You need to have that kind of thinking trained, right? I need to train you guys to think this way. So this is really more of a way of training you to think in a more analytical fashion. So that's what we're doing. All right. All right, last one here. This is unit circle stuff. This is just review. Review of unit circle. Here we go.
How much math do you have to take in college?
Depends what you major in. If you're aiming to do, like, I know a lot of people do business or finance, so you definitely got to do calculus. Probably something called linear algebra, which is on like matrices, like organizing numbers and
What about stats?
totally stats. Probably even 2 stats classes, like a basic and a advanced.
Even stats might do
I
that.
would say a couple years probably. And then you do stuff for your major. I mean, I was an engineering major, so I did like the equivalent of AB, the equivalent of BC, the level after that, and then 3 more classes after that.
Use a level after BC.
Yeah, that's like multivariable calculus. And then there's linear algebra, vector calculus, and I can't remember the other one. Differential equations. That's another one too. Yeah. Then yeah, you might be just do one easy calculus class. It just depends what you're majoring in. All
That's a cheese.
right, 390. Tell me when I should stop, guys. When should I stop?
Stop.
Okay, thanks. By the way, let's talk about reference angles. Now we talked about it. What's the reference angle here? If I did 390. 30. Thanks, James. It's 30 degrees. So what this means, I'm just gonna look at 30 degrees. The coordinates there are gonna be √3/2, comma 1/2. And this is unit circle, right? Actually, I already wrote that. I'm writing again. This is unit circle, so sine is just gonna be the y coordinate. So it's 1/2. That's all. So now you know about reference angles, you can actually do this more quickly. Let's look at -150. Okay, I gotta go clockwise now. Tell me when I should stop. Okay, thanks. Thank you, Anthony Romar. So you have that right. Okay, what's my reference angle? No, it's gotta be acute. If I did -150, we should say 30 degrees. Okay, so what are the coordinates at 30 degrees? I know it's the same thing as the previous problem, but x and y are both negative, however. And it's gotta be x on the inner circle. So you get -√3/2.
So here's the deal. I have this memorized. That's good. I just have memorized. But all you need to know is the first quadrant. You just make an adjustment. If you're in the third quadrant, make x and y both negative. If you're in the second quadrant, make x and y positive. If you're in the fourth quadrant, make x plus y negative, so forth.
So my reference angle is 30 degrees. That's reference. All right, last one. And then you guys can go ahead and start homework. Okay, guys, quiet. We're almost done. Yeah, that's all right. No worries. You guys are getting excited over other stuff. It's not the most exciting stuff. I get it. All right. Tangent -π/2. Here we go. -π/2 is -90 degrees. Hope you guys remember that. -90 degrees right here. Right here. Okay, where are the coordinates there, by the way, on the unit circle?
0, -1.
Thank you, Iris. 0, -1. Tangent is y over x. So we need -1/0, which is undefined. Yes, circle.
But you gotta understand that you have to, how do I rotate this clockwise? And pi/2 is 90 degrees because 2 pi is 180. That's right. 2 pi is 360. Pi is 180. But you know, your unit circle is gonna have a pi root anyway, so you'll know where to stop.
So this is stuff that we're gonna start being more fluid with this stuff. So on Thursday, we're gonna start reviewing. I'll put problems on the board. Maybe we'll go in the hallway, but I'll put stuff on the walls. That's kind of fun to do. We haven't done that in a while. And yeah. And we'll just do some more practice problems like this stuff. So all right, cool. So that covers this lesson. Homework is just going to be this right here. You guys have this? Do you guys have these problems in your packet, the homework packet?
No, not the homework packet.
Not the homework packet.
Oh, wait.
You guys should have this, I think.
Yeah, we did.
Okay. Okay, cool. So work through these problems. I'm actually gonna make the answer key for this because there's no answer key for it right now. So I'll print, I'll make an answer key. I'll scan it so you guys can see it. By the way, in Schoology, I also in Schoology, I put a link
To have all the videos, so if you ever need to watch old videos, I already uploaded that, so it's all set now. So every time I upload something, it's this playlist will automatically populate. So you have that as a resource.
Thursday, I'll have test review materials. So if you guys want to get a head start, if you guys want to use the weekend, it's supposed to be really hot this weekend from what I hear, like almost 100 degrees. So kind of crazy. But homework is just gonna be all these problems. So if you want to get a head start, go ahead. If you need a little break, we've got 13 minutes till we head to the next class. That's fine too. Anyway, so that's the story there. Hey, Claire, what's up? I'm upgraded. Oh, no, we don't. Yeah, hold on. Yeah, we do. You know, I may have. Yeah. No, that should have been turned off. Hold on. Let me see. Let me stop recording. Yeah, I'll totally turn it off.
How do we know it's like?
Hold on, James. All right, stop sharing.